Hello, algebra students. We continue our study of inequalities with two examples here. This time we're given a graph and we're asked to write an inequality that represents or matches up with that graph. So first here we want to notice this is a closed circle, so that means something in particular. Remember, it means or equal to. All right, so it's going to be that type of inequality that's non-strict, right? And it is going to the left, so it's going to be less than. So we'll use x as a variable. It doesn't really matter which variable, but we'll stick with x for now because that's very common to algebra. So this is x is all of the numbers that is less than or equal to -3. So we'll write it this way. X is less than or equal to -3. Right, so that's the first one. Change up some colors here. This time we have an open circle. Right. So that means it is a strict inequality. Strict inequality. All right. So this is, we'll use x again. X is any number that's greater than, because it's going to the right here, is greater than -19. And there you have it, two quick examples on how to write inequalities using a graph. Now let us continue our study with some word problems. So the current minimum wage in the United States is $7.25. Depending on when you're watching this video, what year you're watching this may not be true anymore. But for the sake of the problem, let's just say it's $7.25. You get hired for a job mowing lawns for a company, a law-abiding company. What are the possible amount of monies you could make hourly? Well, let's start with the variable. Let's say P here is the amount of money is your hourly wage. Okay. Well, there are a lot of possible amounts. In fact, there are infinitely many. You could make $7.25. You could make $7.26. You could make $8, and so on. So and there's actually infinitely many answers to this question. So the way we can do that is with an inequality. The amount of money you make, the hourly wage, is greater than or equal to 7.25, assuming that the lawn mowing company here follows the law. Let's keep going. 1/3 of a number t is less than or equal to 5. So let's start out with t here is a number, right? And 1/3 of that number, so 1/3 times t, is less than or equal to 5. And there you have it. Now, what I need to do for both of these problems is also to graph them. And by comparing how we write these inequalities with how we graph them, you'll see the power of using graphs. So for the first one, it's fairly simple. I have a number line here that goes from -infinity to +infinity. P is the variable in question, and P must be greater than or equal to 7.25. Therefore, we are going to have an arrow that goes to the right, and because we have or equals, it's going to be a closed circle there. Okay. Now, number 2 is a little bit more interesting because we have an inequality not in terms of t, but in terms of 1/3 t. So before we can graph it, we really have to do a quick algebra step. Multiply both sides by 3. So multiply the left side by 3, multiply the right side by 3, so that those two fractions, 1/3 and 3, cancels out. So now you have left with t is less than or equal to 15. Okay. And with that in mind, now we can draw our graph. We have the number 15 here, and then it would be a closed circle as well because you have or equal to, and it's less than, so we're going to go to the left. Okay. So this blue arrow here or ray right here represents the value of t, and it must be less than or equal to 15. All right. Now let's go on forward, and let's talk about a little bit more interesting example here. There are 65 people in a restaurant. The restaurant has a maximum capacity of 84 people. Write an inequality that represents the number x of additional people who are allowed to enter the restaurant, assuming the restaurant will enforce its capacity level. So let's start out this way. There are 65 people in a restaurant, right? And we're going to add additional people. We don't know how many, but we're going to add x of them. And you can't add too many, right? You can't add like 1 billion people because they won't fit in the restaurant. You can't even add 100 or even 30 because that's too many. Well, the number that are currently in the restaurant and the number of people that could come into the restaurant is at most, okay, or it is less than or equal to 84. Okay. So let's put some more detail into this a little bit. Number of current people, number of people already in the restaurant, okay. And this is the allowed number, or the number of allowed additional people. Well, that sounds very weird. The number of additional people who can enter the restaurant, right, assuming no one else leaves. Okay, so 65 plus x must be less than or equal to 84. But before we can solve this and really answer the question, we have to get x by itself. So to do that, we're going to subtract 65 from both sides. So subtract 65 from over here and subtract 65 from over here, and we'll get our results on this side. So we'll get x is less than or equal to 84 minus 65 is 19. So in other words, the number of people who can enter the restaurant would be at most 19. So to show you a graph of this here, here's the number line, here's the number 19, and then I'll just change colors real quick. The number of people who can actually enter the restaurant is this blue arrow right here. It is any number that is less than 19. Okay. Well, we would normally be satisfied with that answer, except we really should change it a little bit to meet the real world scenario, because if we were to keep on going, eventually you would get down to 0 and then you would get down to -1, and it doesn't quite make sense to talk about -1 people, right? It does make sense to talk about 0 people, but it doesn't quite make sense to talk about -1 and -2. So let's modify our answers just a little bit. All right, let's modify our answers to indicate for the fact that the number of the people who could enter a restaurant is less than 19, but it is at least 0. Okay, so it can't really be that small. I mean, it can't go into the negatives. So x can be any number between 19 and 0. And this 0 here, we're including this because it applies to this particular situation. If we're talking about people, you cannot have negative people. Now, if we're talking about temperature, you may have negative temperatures, and that might make sense. But in the context of people, you got to stop at 0. So you see here, this is actually the introduction to something called a compound inequality, where you have two inequalities that have been merged together. All right, as always, ask for help if you need it. Keep working hard. Thank you for watching, and have a wonderful day.